All right. Had to reset my phone there. So effects of aging on bone. As we get older, we have reduced protein synthesis. That happens, that affects our osteoblasts. Osteoblasts. So we're not secreting protein. We're not forming new bone. If we're not forming new bone matrix, so we're going to say less bone matrix being formed. So as a result, our bones are going to get brittle and they're going to be much more susceptible to fractures. So there's two stages of what can occur. The first one is called osteopenia. So literally, if you've had medical terminology, means bone poverty. And that means we are absorbing our bones so much more than we are depositing. So osteoclasts are much more active than our osteoblasts. So our bones get more porous, so more holes in them, and they get lighter as we age. This is something that just happens with aging. We stop laying down new bone generally in a female around age 30. And after that, it's all just about minimizing bone loss. At that point, we're not really going to build new bone. We're just trying to slow down the loss process. Now, this is expected. It can continue to osteoporosis, meaning bone is in very poor condition. This is a condition that primarily affects postmenopausal women because estrogen helps maintain bone density. So we would say postmenopausal women, so women who have gone through menopause, postmenopausal women. It can happen to men, but men have significantly less estrogen than women, but it can happen to them too. So postmenopausal women whose ovaries have stopped producing estrogen. That's what happens in menopause. The ovaries stop producing estrogen. This also happens to someone who's had their ovaries removed, or someone whose ovaries may have been destroyed with chemo. So it can happen in several ways. So basically, the ovaries are not secreting estrogen for some reason, whether surgical removal, whether by chemistry, natural aging process, postmenopause. They're going to be at risk of osteoporosis. So we try to keep that from happening. So we're at risk of fractures. What the heck is a fracture? All right. It's a break in the bone. A fracture is a break in the bone. Now, there's different types of fractures, which we'll talk about later. But let's talk about once we have broken a bone, we are going to fix it. And let's talk about the biological processes involved in fixing a broken bone. So the first thing that happens is the broken bone is what is called reduced. That means it's realigned. You hear this in the hospital as somebody comes and sets the bone, where they set it. Reduced is the proper term, but so someone who sets the bone, realigns it, and then they put it in the cast so that the bone stays immobile and it can heal itself. Generally going to heal in about 8 to 12 weeks for healthy young people. Depending on the degree of the fracture, it may be less time, it may be more time. But there's 4 phases. So let's talk about them, and then I'm going to show you a picture, okay? Almost done. Y'all are doing awesome. So 4 phases. First one is called hematoma formation. So this is a blood clot or bruise. So you have inflammation, you have a lot of swelling, and then any of the cells that don't have oxygen as a result of things getting broken, vessels getting destroyed, they're going to die. We don't want them to die, but they do. Next is called fibrocartilage, fibrocartilaginous. So fibrocartilage, cartilaginous. Callus, C-A-L-L-U-S, formation. What the heck is that? All right. So the callus, just like on your skin, means thickening. So it's thick skin. In this case, it's going to be thick. It's going to be a thickening of some fibrocartilage in the area where the bone is. So soft, granular fibrocartilage tissue is going to form. So you've got capillaries, that would be your blood supply, is going to come into the area because, again, without blood supply, our tissues will die. Phagocytic cells, that would generally be the immune system. So white blood cells are going to come in and they're going to eat things up and clean up that debris, clean things out, also help prevent infection. Fibroblasts, these are the ones that are parts of the connective tissue. They're going to make the collagen fibers, and that's going to connect the broken pieces of the bone back together. And then they're going to become the chondrocytes. So they're going to start having cartilage. So they're going to produce collagen fibers. Then we're going to put the rest of our cartilage matrix. And then our osteoblasts are going to come along and start laying down some spongy bone, start to calcify that. Next, so that's your fibrocartilaginous callus formation. Next, you have a bony callus formation. So bony callus formation. This is where your osteoblasts and your osteoclasts work together to lay down and make this bone. So it's no longer going to be cartilage, it's going to be hard bone, just like the rest of it. And then you have the last thing, which is bone remodeling. So we're going to come in, we're going to shape it. So we're going to remove the excess, make it look basically good as new. So we're going to try to make it look good as new. And the way that happens is it's going to happen according to Wolff's Law, which is going to say bone is going to change shape as necessary to how stress is applied to it. So it's going to be good as new as the various stresses or stressors of our normal life or wear and tear reshape the bone. So areas where there's lots of pressure, you're going to get thicker bone and such. So let's look at what that looks like. Here we go. Page 237, fracture repair. What is the word in, oh, in quotes, this is good as new. Good as new. So ultimately, your new bone that's formed is going to look the same over time as, so if you break one arm, it's going to look the same as your other arm as you go throughout your normal life. Where you had a little bit too much laid down while you're healing the bone, it's going to go back and look normal. So let's take a look at this on page 237. Here is the break in our bone, right here. Right here, here's the break. So it's going to be a blood clot. So there's our blood clot, fracture hematoma forming. That's the first stage. Next, this is the soft callus. Right here. This is a fibrocartilage. So fibrocartilage comes in and starts to heal. So this is soft. It's not going to be strong at all. Then our osteoblasts and our osteoclasts are going to come in, and they're going to form this bony callus. So everywhere there's fibrocartilage, they're going to lay down some bone matrix here and make this hard. Now, you see here, this is thicker than the rest of the bone. This is thicker. So this is your bony callus. So it's a thickening of the bone. This is part of the healing process, but we don't want it to stay that way. We want it to look much more like normal, so that over time the bone's going to be remodeled and this callus is going to go away. This is going to end up becoming compact bone where it should be compact, spongy where it should be spongy, in response to the normal stressors. So it's going to take some time for this thickening area to go away, but ultimately we'll get back to normal, or as close to normal as we can get. So let's talk about types of bone fractures. And this is the last thing we're going to talk about related to this chapter anyway. Thankfully, this is a fairly short chapter. Okay, so you can have, we're going to talk about 8 types of fractures. There's actually more than that. It's kind of crazy though. All right, so you can have a complete fracture. That's where your bone is completely broken into 2 or more pieces, but it stays in the skin. You can have a compound fracture, and this is where one or both of the broken ends actually poke out. This is what completely grosses people out. So you see bone sticking out where it's definitely not supposed to be sticking out. So not only is it completely broken, it has poked through the skin. Next, you can have a compression fracture, and that's where the bone literally gets squished. So if you fall down real hard, you can fracture your vertebrae, be a compression fracture there. Now, this is a bad one. This is called an epiphyseal fracture, and that's where it happens on the epiphyseal plate. So remember, this is the end of the bone where growth tends to happen. It separates the end of the bone from the shaft of the bone. So when that happens, it can interfere with future bone growth. You can have a green stick fracture. This got its name if you, since it's now spring, if you go out and you look at like a green limb, so a young limb. This happens in children. It's very bad. It's one of the signs they look for of potential child abuse. It's a partial fracture. So one side of the bone breaks and the other side is bent. So it's kind of like a splintering is what it looks like a little bit. You can have a hairline fracture. This is a very small crack, but everything stays aligned, so you don't have to reduce it. It doesn't necessarily have to be set. They'll do the x-ray and they'll be like, oh, okay, this is just a hairline fracture. We'll just put you in a cast and it'll heal in a couple of weeks. A lot of times I've known people where this has happened to their wrist, and so they're only in a cast for like 3 weeks or so. But heavy bones, so they're aligned. Nobody has to come in and move it. It's not necessarily into complete pieces. Now, you can have a simple fracture. A simple fracture is any one of them where the bone does not poke out of the skin. So most all of these are also simple except for compound. So it's simple, all these are simple unless it pokes through the skin, and then it's compound. If it pokes through the skin, it's compound. It's gross. Now, the last one we're going to talk about is a stress fracture. Those are fairly common now, and these are very thin hairline fractures. Fracture number 5 is a green stick. Green stick, one word. green stick fracture. So a stress fracture, this is very thin, but it's a result of prolonged, repeated impact. So a lot of times this happens to runners. It can happen to athletes, generally athletes of various sources. A lot of times it's going to be in one of the bones of the lower legs. So tibia, fibula, maybe somewhere down in the ankle. Sometimes it'll happen in the feet, depending on what, like if you're wearing the right shoes, if you spend a whole lot of time running only on pavement, only on a trail. But these are, they're not good. And they're actually really hard to diagnose because they may or may not show up on an x-ray. So let's look at kind of what these might look like. So here, page 236, I may or may not be able to, we don't have pictures of all of these. All right, see, look at all these on here. Complete fracture, compound fracture. Here's a compound fracture over here. So the bone is broken into two pieces and one of them sticks out through the skin. That's gross. Generally, this person is gonna have to have surgery and they're gonna have to put it back together with pins and rods. You can have a compression fracture where the bone gets squished. So that would be this part right here. It's squished and so it breaks apart. Here's a green stick fracture over here. So this part is splintered. This part here is splintered and this part of the bone is bent. So this is, that's a collarbone there. One breaks, the other's bent. Those are all the ones that we have pictures of. That's sad. But that is it. Videos, I will post my actual YouTube videos as normal to my YouTube channel. I want to thank you all for being here in class today.